Dr. Arora sir. Sir, this is Sindhu Chopra. Sir, एक request करना था sir. Hello. सर एक्चुअली सर हमारी IRC 2 चल रही है जिसमें सर अभी हमारी अपनी डिवीजन की है सर, जिसमें सर मेरा काम प्रेजेंटेड है। तो मैं लाइव स्ट्रीम सर जब मेरा मतलब स्टार्ट हो जाएगा उस वक्त तक सर मैं लाइव स्ट्रीम पे ज्वाइन कर सकती हूँ सर प्लीज, मतलब यूट्यूब पे लाइव स्ट्रीम। थैंक यू सो मच सर।
हाँ डॉक्टर साहब।
Good afternoon, everyone. We are now back after a break on the second day of the National Training Program on Soil Health Management Concepts and Practices. So we will be having two lectures from eminent speakers, Dr. Puneet Chaudhary and Dr. Aziz Mujtaba, discussing on the different aspects of soil health management. I request course director Dr. Pradeep Kumar Rai to start the technical session in the second day of afternoon so that we can complete it timely and have a discussion at the end.
Okay, thank you, Dr. Arora. And in this session, the first lecture will be delivered by Dr. Puneet Chaudhary. He will discuss about what is the role of agroforestry in soil health management. So, Dr. Puneet Chaudhary is the Chief Scientist Agroforestry and Head Krishi Vigyan Kendra Jammu. He did his PhD in agroforestry from Y.S. Parmar University of Horticulture and Forestry, Nauni Solan, with certificate of honor. As a principal investigator, he completed 5 externally funded projects, and presently 2 projects is going on under his leadership. He is selected as a facilitator under the National Facilitator Development Program by Manage Hyderabad in this year at national level. He remained certificate trainer of Agriculture Skill Council of India for vermicompost producer job role in 2016 for Krishi Vigyan Kendra, and organized 200 hours certificate skill development training course on vermicompost. He worked as a collaborator in the Unnat Bharat Abhiyan project. He is instrumental in the establishment of Amla Mango, Harad, Basmati and Mushroom Farmer Producer Organization in Jammu district. He has published 46 research papers in national and international journal, more than 50 extension papers, 5 training manuals, 4 books chapter in his credit, and 1 edited book entitled Technology Application and Adaptation for Climate Smart Agriculture. He is the recipient of medal in international conference organized by European Union. He got a Young Scientist Award by the Society of Krishi Vigyan in 2018. He is a team member of the Pandit Deen Dayal Protsahan Puraskar 2016 of Krishi Vigyan Jammu by Ministry of Agriculture, Government of India. As a head of KVK Jammu, he received the Krishi Alert Award in last year for KVK under the Food Processing Initiative category by the Krishi Alert under eminent affiliation with ICR, APIDA, Manage Hyderabad and Niti Aayog among KVKs across the country. And second presentation award got by ICR in Northern Zone by Atari. So, and he is the life member of many prestigious national and international societies. So now I request Dr. Puneet Chaudhary to kindly join us and deliver his talk on what is the role of agroforestry in soil health management. So, Dr. Puneet. He has already joined. Now I request Dr. Puneet.
During the technical sessions, participants can note down the queries, if any, and some point if they can add at the end of the technical session. Meanwhile, Dr. Puneet will be ready to deliver that talk. डॉक्टर पुनीत, आवाज नहीं आ रही है। माइक्रोफोन चेक करिए।
Sir, I'm audible. I'm audible now.
Yes, yes, it is now.
Okay, okay. Sir, screen sharing enable कर दीजिए, please.
Dr. Rai. मर्थला।
हाँ, डॉक्टर राय स्क्रीन शेयरिंग एनेबल कर दीजिए।
वो जो शेयर स्क्रीन वाले को दबाने पे
सर होस्ट डिसेबल्ड अटेंडी स्क्रीन शेयरिंग आ रहा है सर, अनेबल कर दीजिए।
डॉक्टर राय, आप वहां पर हैं?
हाँ, मैं हूँ।
आप एक बार होस्ट ट्रांसफर कर दीजिए मुझे, मेरे नाम पे क्लिक करके। अब देखिए डॉक्टर पुनीत।
हाँ सर, जस्ट मिनट। हाँ सर, अब हो रहा है।
वो बनी थी ना पॉइंट, उसमें था ऊपर।
हाँ, ठीक है सर, थैंक यू। Sir, good afternoon. Thank you very much. I first of all thanks all the organizers, including Dr. Sanjay Arora and Dr. P.K. Rai for providing me this opportunity to have a talk with all the participants regarding the role of agroforestry for soil amelioration. Thank you very much, sir. Soil amelioration and
can you put your slide in slide mode, presentation slide mode?
it is in slide mode.
Okay, carry on.
Okay. So thank you very much and welcome all the participants to this training program. There are two things that if we talk of agroforestry systems and soil amelioration, they are basically simultaneously acting upon each other. Agroforestry means cultivation of trees on the farm abundant boundaries and outside the conventional forest. And the areas which have been denuded, which has been depleted, immediately need their amelioration for soil conservation and soil, you can say soil protection measures. So agroforestry is one of the component which we can use it for this soil amelioration purposes. Since what we'll talk of agroforestry, what basically it is. We say that agroforestry is a combination of trees, agriculture crops, animals, fodders, etc. If we talk of it in definition way, it is simply a collective name for a land use system which involves tree animals on the same unit of land. There is a word be either in a sequential arrangement or in some way of temporal arrangement. That means it has to be on the same land management system itself. First of all, same land management system means within the area we have all the components interacting with each other. There will be a horizontal as well as vertical interaction among all the components. It may be a agriculture crop, it may be a tree, it may be a horticulture tree, it may be a fodder tree, it may be a multi-purpose tree providing small timber, fodder, etc. to the farming community, or it may be any pasture, grasses, or we also sometimes rear animals within the same land management unit. So that is why we called it as a collective land use system.
Sir, you are not audible.
Hello.
Yeah, your slide is not moving.
No, it will move. I am just explaining it.
Okay.
That it is the production of multiple outputs with protection of the resource space. This is the basically the main theme of agroforestry system. Then we call it as it plays emphasis on the use of multiple indigenous tree species and shrubs. We can't advocate any land use system where we can grow exotics within that. Third one is the particularly suitable for low input conditions. Then it involves the interplay of socio-cultural and for the people. So that is why we say that there is a much more socio-cultural values involved in that particular land use system. It is structurally and temporally more complex as compared to monoculture. When we talk of monoculture, there is only one crop, but here we have got a different components within the same land management system. So it is structurally more complex as compared to the monocrop system. So this is the scenario where we say that we have to bring area under forest. At present, 80 million hectare area is under forest, that constitute about 25% of the forest land. But we need to bring more 24 million hectare areas, and an additional 31 million hectare degraded forests are required to be revegetated and rehabilitated. So this is the scenario of the Indian conditions, and we want to add more tree component on that particular area so that we can increase the forest cover or tree cover under the, you can say, forest. In next 20 years, we aim to rehabilitate or raise plantations on 2.7 million hectare annually against the present target, which is around 1.2 million hectares. You can see very well how much budget requirement will be there when we want to raise the tree component outside the forest. So this is the scenario of agroforestry in India. We have got a traditional agroforestry system, which is almost near to the 10 million hectares. We have got a shifting cultivation, that is around about 2.28 million hectares, home gardens, 2.42 million hectares, scattered trees on the farm burns and boundaries. This is the main thing, 4.45 million hectares. And what area has been brought under agroforestry system is past 20 years is almost 16.8 billion hectare areas. And what planning commission estimate to that an additional area that could be brought under agroforestry system is 28. So there is a potential of agroforestry systems in overall agriculture scenario, that we want to raise the crop, we want to raise the trees, we want to raise the animals in a same land management unit, and we want to have a multiple benefits from the same land management unit. These are some of the examples of agroforestry systems. Land pressure for multiple cropping. We can't go for the horizontal expansion. So that's why we need this agroforestry system. You can very well see there is a pear trees growing. There are poplar, and in between the poplar, advanced generation of mango plantation is there. Similarly, when the poplar has been raised, we have got interspecies which has been covered by the bee boxes to rear the bees, that can provide an additional income of from this apiculture segment. Another, you can see poplar and kinno plantations, and you can see very well that there is an simultaneous growth of these plantations. Once the age of the kinnu is there, that there is a sustainable income throughout the coming years. Here we can see the marigold is growing between the poplar and kinno, so that we can very well utilize the interspecies to have all these type of systems possible within the land management unit. It may be either in the North India, South India, or anywhere, but we want to have a sustainable land management unit, and that is what we called it as a agro.
Dr. Sir, you are not audible. Dr. Puneet. Dr. Puneet. Dr. Puneet, you are not audible.
Sir, I have informed Dr. Puneet. He is trying to repair it.
Dr. Puneet is trying to join. There is some problem in the speaker. His audio system is not working.
अबे चाह बोले पप्पा क्या और ज्यादा रात रहे जीवन 25 रुपए में निपटा देते तुम समझ सकते हो अगर तुम एक्टिव नहीं हो तो मैं
Okay, dear participants, in the tomorrow we have one more day of this training program, and after finishing this training program, there is a quiz in the session. So evaluation quiz. So all the quiz questions will be asked on the basis of the lecture delivered during this training program. So be ready for that also. In between, Dr. Puneet is trying to join again.
stop sharing. Presentation done. Just to you to see.
Now you
डॉक्टर राय, आवाज आ रही है?
yeah.
ओके, हेलो जी सर, मी पता है। ठीक, मैं थोड़ी देर बाद करना तो कॉल बैक, फाइनल करिए। ठीक, रियासी से सूटेबल नहीं है, मैं करना थोड़ी देर तक करना कॉल बैक। ठीक,
Yes, Dr. Puneet.
हाँ सर, आई एम ऑडिबल?
Yeah.
Okay. I was talking of agroforestry, what agroforestry was, and what are its component, and how we can get a multiple output from the agroforestry systems. So I have talked of the planning, how the India is planning to bring 1/3 of the country under forest. So how much area is under forest, and how much more is needed to be planted, and how much additional degraded land to be required to be revegetated or rehabilitated, so that we can cover the target of 1/3 of the area should be under forest cover. So this was the scenario of the agroforestry in India, that how much is the total available agroforestry system, and how much we have to, what is the future target in 20 years, and how much we have to convert it to the next level, so that we can cover the targets in the Indian conditions. These are some of the pictures of the prevalent agroforestry systems in India, that how these North Indian conditions, what are the different components which we can cover under these agroforestry systems. So we were talking of this particular example, that if we talk of woody perennials, we talk of animal or tree pastures, how we designate a particular agroforestry system. You can very well see when we talk of these two systems, like agroforestry, animal and pasture oblique woody perennials, we will designate as a silvipastoral system, which is a prominent system in the hilly regions, where we can grow woody trees, we can rear the animals for the milk, etc., anything else, and we cultivate the fodder grasses, or we can cultivate the fodder crops. But when we don't rear the animals, we just cultivate the agriculture crops along with the woody perennials, then we define it as a agricultural system. So this is how the agroforestry system is designated. And if we talk of all the three components together, we on a same land management unit, we say it as a agro-silvo-pastoral. That means we have got agriculture, we have got woody perennials, and we have got animal oblique pasture sector within the same component of the tree. This is how we designate a particular system under agroforestry systems. So these are the traditional agroforestry systems in Jammu conditions or J&K condition. You can very well see we have got trees on bunds and boundaries and open areas where we cultivate the crops, or we rear the animals on the fodder crops, which are being reared in the interspaces between the trees, or in the, you can say, on the slopey lands where terrace type of farming can be cultivated. Here in plains, if we talk of, we can rear these fodder grasses on the bunds and boundaries of the agricultural lands.
Doctor, sorry to interrupt you.
We can, sir,
slides are moving on or not?
No.
No. This is still first slide. That is.
Okay. Should I mail you?
Yeah, now it's okay.
Now it's okay?
Yeah.
Okay, we will continue this type. It's okay now?
Yeah.
Okay. So what are the characteristics of for agroforestry? Because we are talking of soil amelioration, we are talking of soil health, and what type of trees which are best suited under these agroforestry systems. First of all, we select a species which suit the soil and site condition. That means we always prefer to have an indigenous species rather than any exotic species. Then it should be capable of providing the desirable products and services. it depends upon the objective of a system. That means if the objective is to provide fuel wood fodder, then we have to select a tree species which provide a fuel wood fodder. And if the objective is the soil health management, soil amelioration, then we have to go for the nitrogen fixing trees, deep rooted trees, which can hold the soil, which can prevent the soil from erosion, and which can fix the atmospheric nitrogen into the soil. Trees should be fast to light, fast to medium growing. That means it should not be very slow growing. It should have a light branching habit. Then it should have a straight single stem with a clear bole. It should be resistant to disease and pest. It should have less competitive with the crops for water, light, and nutrient. Because once the trees are grown, it always have the tendency to compete with the agriculture crops for these particular water, light, and nutrients. So selecting a species which should have a deep root, which should be a leguminous preferably, which should be a nitrogen fixer, which should be a multi-purpose tree, and which should be a rather light demander, and should have a very deep root and tap system. And the leaf litter and the litter decomposition rate of a particular species should have a positive effect on the soil. So these type of characteristics should be followed while selecting a particular species for an agroforestry purpose, and especially when we're talking of soil health and soil amelioration. These are some of the other benefits from the agroforestry. I will not be elaborating upon that. Environment benefit, everybody knows that when the tree component we add on to any component, it should have a better environment, microclimate, etc. It should have a benefit of economic enterprise, because other crops may fail, but when the tree component is there, it will definitely provide some sort of income or some sort of sustainable income to the farmers. It has a social benefits attached with them also, but there are certain limitations also that under agroforestry environmental aspects are there, socioeconomic aspects are there, that people are bound to these trees. They don't want to fell these trees at the time of harvesting stage, which later on becomes provide some sort of negative increment on these particular systems. So these things has to be kept in mind while designated or designing any of the agroforestry system. So these are some of the potentials agroforestry where they have got the potential. Once the agroforestry system is there, we have got an overall higher biomass productivity. We want to prevent the deforestation. Soil amelioration is there. Nutrient cycling is there. Microclimate improvement is there. Now another term, what we called it as a carbon sequestration, that is a important component of mitigating, how we mitigate a climate change scenario in a particular agroforestry, in a particular land use system. This is the important aspect where agroforestry has got a potential. Then bio drainage is another factor where these trees can help. A large number of trees has been planted on areas where there is salinity, where there is a threats of water pollution, etc. Just like Tasmania and all that. Then bioenergy and
देखिएगा क्या
biofuel is
होगा ना कि
another
आंखों के
component.
सामने से गुजर जाएगा, फिर हो अरे नहीं 1 लाख तक का ही लिमिट है इसमें, सॉरी सर.
Where we can cultivate for higher fuel mass, that is bioenergy, biofuel, greater biodiversity. When we plant a tree, it will have a better environment, and it will have a better biodiversity area within that, cleaner water, and less land erosion will be there once the tree component or agroforestry will be there. Then it also helps in poverty alleviation and employment generation, that I will talk on later on. This is how the livelihood scores to agroforestry can be contributed. Agroforestry contribute to the livelihood scores through your large number of benefits, because most of the farmers which are having small and marginal farming having a higher rate of financial returns from these lands. It will generate productive self-employment to the small farmers and their family members. The capacity of the small and marginal farmers is enhanced through trainings, improve the health and nutrition of the people by providing diverse, nutrient-rich farm produce and multiple outputs from the risk of total failure, which is in the case where you can see a large in the few years where there is a change in the climatic scenario or a weather scenario of a particular areas where, for example, we have got a you can say a flood-like situation in the last Kharif season where whole of the basmati get damaged. Similarly, in last few years, when the crop is going to mature, there may be a hailstorm, there may be something else has happened where the crop failures, risk of crop failures are there. In that case, we can have a multiple output from this agroforestry system. This is how the employment generation can be done through agroforestry. You can see these are the various agroforestry systems. Silviculture system is there, agri silviculture is there, rain-fed irrigated agri horticulture is there, silvipastoral is there, tree bearing oil system, which is nowadays a very common fact that most of the trees are grown for their oil production. So in that case, you can very well see that how the total employment per million persons per day, man days per year has been generated through these agroforestry systems. These are the views of the agroforestry systems in our Jammu conditions, mostly in the Kandi area. You can see the mango plantations are there. In between the mango plantation, agriculture crop is being raised, and on the bunds and boundaries, fodder grasses are being raised. Now we were talking of carbon sequestration. Carbon sequestration means how we can sequester the carbon to the so that we can have a net carbon credit to our worth also. So in that case, agroforestry plays an important role in that climate changing scenario, where it is the important mitigation strategy where agroforestry helps in carbon sequestration. You can very well see it has got a direct role in carbon sequestration, where carbon sequestration rate ranging from 0.3 to 15.2 megagram per carbon tons per carbon per hectare per year has been reported under agroforestry system. Under the indirect role, agroforestry has also some indirect effects on carbon sequestration since it helps to reduce pressure on the natural forest. This is how the direct and indirect role of agroforestry system for mitigating climate change. What climate change, you all well know that how the temperature is being raised, what IPCC prediction is there, and why we say that climate is changing. What is climate? Climate is what you expect, and weather is what you get finally. So if we say that carbon dioxide concentration has risen from 275 ppm to so much of ppm up to the current value of 400 ppm. So this is what we called it as a climate changing scenario. So these are some of the causes and effects of the climate change, where deforestation, pollution, increasing population, threat, biodiversity, floods, degradation, hunger, malnutrition. These are some of the causes and effects of the climate change. Very well, we can have a factors which contributes to these particular, you can say, causes and of the climate change. These are some of the factors which leads to the global warmer climates. You can see how the climate change projections for India has been depicted in Kharif season, annually Rabi season, and with respect to 2020 to 200 to 2080s. This has been projections based upon the agroforestry system given by the Lawlett et al. This is how the impact of climate change is basically going on. You can very well say that agriculture potential expand northwards to the higher elevations. Very well see the species or species drift is there. The species which are growing on the tropical climate are now shifting towards like
डॉक्टर पुनीत, आवाज नहीं आ रही आपकी. Hello, Dr. Puneet. Again, you are not audible.
these types of things are happening to.
ब्रेक हो रही है आवाज आपकी. Dr. Puneet. Dr. Puneet. Dr. Puneet. Dr. Puneet. Dr. Puneet. You are not audible.
So there are basic adaptation and mitigation. And what are these adaptation and mitigation strategies? All nowadays must have a clear information of that particular strategies. What are the adaptation strategies? Altered agronomy of the crops, altered dates of planting, priming, alternate crops or cultivars, change in the cropping system, conservation agriculture, zero tillage, super seeders has come up, zero till drills has come up, your direct seeded paddy has come up, conservation of of the soil moisture by these direct seeded rice, by directed by zero till drill, etc. Forage in rotation, integrated farming system is an important you can say option where we can go for adaptation of this climate change. Integrated nutrient management is there, NRM policies are there, risk managements are there, early warning systems and crop insurance. But what are the mitigation? Agroforestry or afforestation system is the mitigation option for this climate change. Watershed management is there, organic agriculture where we use to conserve the organic carbon inside the, and we all want to lock the carbon through the help of carbon sequestration potential. Changing land use by horticulture agroforestry, including the more of the tree component within the system. Integrated farming system can be used both ways. Use of nitrogen inhibitors, fertilizer placement practices, hydrogels, etc. Improved management of livestock, feed and fodder banks, solar powers, etc. These are the things which have got a mitigation potential. So these are the strategies to reduce carbon dioxide. How we can use these strategies? We can reduce the fossil fuel consumptions. We can identify the sink sequestration is there. Aquatic. We know aquatic is the largest sink for these carbon. However, the forests are also known as largest sink for these carbon sequestration. So these are some of the strategies where we can use for these. This is the carbon storage capacity for the agroforestry model in different regions of India. We can see, you can see here the silvipastoral system, which is having a tree component, and pasture has got the highest carbon storing capacity, that is 31.71 tons per carbon of per hectare. And if we talk of what is the contribution of agroforestry produced to national demand by 2025, you can very well see it is 86% of the. So this is how the capacity of the agroforestry systems or models can be estimated on the base of your carbon storage and annual demands. We were talking of these nutrient help in nutrient management. This is the table one is showing that how the nutrients availability has been increased. Availability is there. Nutrient content in the foliage of important tree species is there, which can be used for fodder purposes or for any other purpose. These are all nitrogen fixing trees. These are possible Juliflora, Acacia indica, Leucasia leucosifolia, and Acacia niloticus, generally commonly called as babool. So this is how a tree is planted and how the tree leader, how the tree contributes for a soil amelioration or nitrogen fixing. What are the benefits from agroforestry technology for wasteland development? Land prone to water erosion can be prevented by plantation of trees. Land degraded by wind erosion can be prevented by plantation of windbreaks. Agri-silviculture models for alkali soils are there. Agri-silvipastoral models for soil affected soils are there. Reclamation of mine soils can be carried out by these agroforestry systems. Controlled seepage canals and water bodies can be controlled by these plantation of different agroforestry tree species which from these canals and water bodies. This is the table show 2 is showing that soil fertility improvement in teak based silvipasture in kilogram per hectare when it is grown in open land, when it is grown in pure fodder grasses, when it grown along one plus fodder. You can very well see how the nitrogen, phosphorus and potassium to these values 0.75, 1.29, 4.448 and 6.0. So this is what it shows that how the tree component is effective in improving the soil fertility, especially when we are having a silvipastoral system. It may be a leguminous tree, it may be a tree outside the forest, it may be a fast growing tree, or it may be a timber or any other tree species. These are the some of the other benefits that how the agroforestry controls toxicity, both soil acidification and salinization. They can help to reduce insect pest and associated diseases. They improve nitrogen fixing trees and decomposition of lead drifter environment generation, which is very well known. Increase farm income and utilize waste and food by means of agroforestry system. The table is showing that how the soil different land use system, how much is the soil loss in ton per hectares, how much is the runoff, and how much is the nutrient loss. You can very well see these are the cultivated fallows, poplar, lucina, eucalyptus and bumper grass. How the scenario is decreasing from cultivated fallow to the all the systems where the soil is exactly binded by these trees along with the grasses, and runoff percentage is decreased from through 23% to 0.0. How the role of agroforestry is there in soil amelioration, soil conservation, soil health management, where we can conserve the nutrient status of the soil. We can add on the carbon to the soil so that we can increase the overall organic matter into the soil. We can increase the water holding capacity. We can decrease the runoff. We can increase the, you can say, we can have the different species available which can reduce the toxicity both in acidic as in tiles. No need of adding areas. A large number of agroforestry models have been developed by center soil and water salinity centers at Karnal, where different tree components along with the different forage grasses and crops can be utilized to overcome these acidification and salinization problems. So this is how you can say agroforestry is helpful in overcoming these types of problems and helping soil evolution and management of soil health. So in conclusion, we can say that integration of trees could be a viable option for improving biological productivity, for improving soil health and carbon sequestration, especially on highly degraded soils. It has got 3 attributes. One is productivity. We all know that if agroforestry, their productivity will be high. It will be having a sustainable system that in case of crop failures, it is definite to have some income. And adaptability is another thing where we can adopt it to the local climate so that we can utilize it for better options.
30 टन है तो 15 सेंटीमीटर होगा 2.24 2.24
major role in enhancement of overall farm productivity, soil enrichment through leaf litters, maintaining environmental services such as climate change mitigations, phytoremediation, watershed protections, biodiversity conservation. And what we will call it as a climate smart India, we can develop it through agroforestry practices. So thank you very much all for patience learning. If there is any query, we can answer to it. And it's over to Dr. Rai.
Thank you, Dr. Puneet. You have discussed in detail what is the role of agroforestry in sustainable soil health management. And through agroforestry, we're not only putting or adding the nutrient in the soil, but also it conserves the soil through.
Thank you. Save
the soil from the erosion. And you have discussed different models in which they can adopt according to their available resources and the climatic condition. So now it is open for the discussion. I request the participant unmute themselves and ask the question if they have any doubt or query. Anybody? I think they can put. You can put your question in chat box also.
I think there was
we are not.
Network issue with me. That's why the voice was not clear.
Okay, okay, Dr. Puneet. Once again, thank you very much for sparing the time and discuss in detail about the agroforestry role in soil health management. Thank you from organizing team.
Have a chat box question, we can answer it.
Okay, Doctor. Thank you. Now we are moving to next our speaker, and this will be the last discussion in today's program. And this for this I would like to invite Dr. Aziz Mustapha Azum. He is the assistant professor cum scientist in Division of Soil Science, Sher-e-Kashmir University of Agriculture Sciences and Technology of Kashmir, Srinagar. He did graduation from the Marathwada Krishi Vidyapit, Parabani. And I request all the participants to only mute them. Mute them all. So, Dr. Aziz did his graduation from the Marathwada Krishi Vidyapit, Parabani, and he does his master and PhD from the ISKCOSS Kashmir. He joined as assistant professor in ISKCOSS Jammu, and after that, working as assistant professor in the ISKCOSS Kashmir. He also served as a visiting scientist under the Indian Academy of Science Fellowship Program in 18 and 19. And he is currently holding the administrative post of university as assistant controller of examination also. So now I request Dr. Aziz kindly deliver his talk on the balanced mineral nutrition for soil health management. Doctor, please.
Thank you very much, Pradeep sir. Am I audible to all, sir?
Yeah.
Thank you very much, sir. Thanks once again to everybody. Thanks, first of all, thanks to Pradeep sir and RCM and Division of Soil Science, ISKCOSS Jammu, for inviting me for this lecture. So the topic selected for my deliberations is balanced mineral nutrition for soil health management. For this, basically, we should first of all know what actually soil means. The soil means soul of infinite lives. As I can see in the chat box, there are a lot of soil scientists here. It is well known to all of you. There are multiple n number of definitions for soil. The fifth definitions which I want to convey right now, because maybe there may be some non-soil science participants. Soil is a dynamic, vital, and living resource possessing physical, chemical, and biological properties which enhance or enables the crop to grow for the production. Secondly, it can be also said to be as a natural entity developed by natural forces acting upon the natural material, that is different horizons. Then, but to a farmer, the soil is a portion of the earth's crust which he cultivates and which in return provides him food in this in the manner of crop. But for soil scientists, and currently the soil has got a definition that is it is a three-dimensional entity having a definite atomic structure, chemical composition, and biological properties which support the life, let it be microflora or microfauna. Coming to the second, now what is soil health? From agricultural point of view, as you can see, the soil health may be referred as the ability of a soil to produce crops in a sustainable manner, which is governed by a number of physical, chemical, and biological attributes. The soil health has been given importance here, and particularly the ANRCM, they are doing a wonderful job by taking the soil health in consideration, because right now it is the health is the important issue of the soil, which is getting deteriorated day by day. Because right now I am mentioning here governed by N number, that is physical, chemical, and biological. Regarding physical and chemical, we are doing certain things, but regarding biological attributes, we are doing a very little, particularly from the perspective of soil science. Then soil health, it is actually the continued capacity of the soil to function as a vital living ecosystem that sustains plant, animal, and human life. It is the definition which has been devised by United States Department of Agriculture in collaboration with the National Resource Conservation Services in 2021. The continuing capacity of the soil to function as a biological system, increasing soil organic matter, improve soil structure, water, and nutrient holding capacity, sequester carbon, and reduce the greenhouse gas emission. By doing these things, by following these things, only then we can maintain the soil health. Otherwise, right now, by indiscrimination, which I will talk in the further slides, continuous indiscrimination and exploitation of the soil and the resources of the soil, we are deteriorating the soil health. Then what is the plant nutrition? Plant nutrition, it is actually when we plant a crop or any plant in a, whether it be a plot, container, pot, or in open field, it needs minerals, that also in an inorganic form. And this complex interactions which are carried away, that is involved in by the weathering of rock minerals, but the basic material is there, the decaying organic matter of the animals, microbes. Finally, it is a microbes which actually help us to take place and form these inorganic minerals in the soil. And roots of these plants absorb these mineral nutrients and ions in the soil by the what we say in the rhizosphere zone. It is a solution form, soil water solution. And the nutrition, it is the supply and absorption of the chemical compounds needed for the growth and metabolism of an organism. Then what is the balanced plant nutrition? The balanced plant nutrition used to refer to the application of essential nutrients in the optimum quantities and right proportions through in a particular time and at a particular there are actually 4 R's, which I will discuss in the next slide, but appropriate method and time of application to the specific crop with a particular agronomic and managemental practices are to be needed and followed. The balanced rate of the fertilizers, it depends upon area to area and crop to crop. Out here, I want to mention here, because in India, we are currently having 20 different agroecological zones. And because of these, we are having 12 different type of soil orders. So the requisite amount of nutrient which is used for a particular plant, it not only depends upon the soil climate, it also depends upon the crop, the suitability of the crop. For this, soil testing is one of the important aspects by which we can go for the balanced fertilization. Then what is the basic concept of plant nutrition? Nearly, it is a basically concept which has been developed particularly nearly about 150 years ago. in which the adequate nutrients which are required, Mr. Leach equation you might have been learning and heard, particularly the scientists must be knowing and the students of soil science, they must know this thing. If we provide all the nutrients in the adequate quantity to the plant, it will grow in a normal and very good condition. But if we just stop one nutrient, that only nutrient will affect and determine the growth of that plant. It means it is similar to the fact that the chain is only as strong जितना जहां पे उसका weakest point होगा, उतनी ही strong वो करेगी जितना उसका weakest link होगा. Then what are the actually aims of balanced fertilization? Number one, we should have an increased crop yield. Then we should have an improving quality for the produce. Then we should have increasing farm income. Then correction of inherent soil nutrient deficiency and toxicities. Maintaining or improving the lasting soil fertility, one of the important aspects of soil health, and reduce the environmental hazards. Right now, in the previous lecture of Puneet sir, they have very well mentioned that climate change is a reality. It is not a hoax. It's not a drama. It is real. Then what are the advantages of balanced plant nutrition? It actually optimizes the quantitative as well as qualitative yields. It maximizes the BC ratio. It avoids the wastefulness of the agriculture inputs in the form of nutrients. And it also helps us to avoid antagonisms. Lowers the incidence of plant deficiencies, toxicities, particularly for some nutrients that also major nutrients, they suffer hidden hunger or luxury consumption that can be rectified. Produces normal and near normal crop even under the poorest conditions of the soil, because there is a large difference between quality and health. Maintains a clean and productive soil. Renders the plant competent by increasing its immunity to stress and pest attack. And again, it reduces the environmental hazards. See out here, you can see right now in the topmost area out here, you can see the blue bar, which is actually the standing bar. Out here, it is mentioned, it is here right now, might be the cursor is showing it. This is the food grain production in the metric tons. See, this bar in 2025, it is nearly 350 metric tons by 2025. While as right now, the NPK demand at that time will be this much, the green bar. And while as right now, the NPK consumption is this pink bar. And the green bar showing the current point is, this is actually the gap of the nutrients, which should be what we say, actually, this is the gap of NPK between the demand and the consumption. There are a lot of certain soil health or hazardous issues in the India. Out of them, number one, out of the 141 million hectares of the cultivation, 104.2 million hectares, that is degraded land. And the degradation, there are a lot of different factors. Erosion is there. And amidst the erosion, wind is there, soil is there. Then salinity and acidity is there. Although right now, the rate is still alarming, but still it can be put on a hold. We can put a hook on those things so that there should not be lost. Because right now, the second point out here mentioned is the annual soil loss, which we are right now facing in India, is 5.3 billion tons. The annual nutrient loss is 8 million tons. It may be in the form of, right now you might be hearing a lot of things of cloudburst, then floods. And due to that, there is not only the soil loss, nutrient loss is also there. And then on an average in India, it is 16.4 tons per hectare per year, the average soil loss. The physical constraints of the crop production losses because of erosion, salinity, and other things. And the another things which are important, which are main factors of the soil health degradation, it is that our soils are very low in organic carbon. There are multi-nutrient deficiencies because of antagonism and synergism between the nutrients and continuous use of major nutrients and delineating and deleting or not applying the micronutrients. Then low nutrient use efficiency, decline in fertilizer response ratio, imbalanced fertilizer use, and crop residue burning. The declining nutrient response, as in this you can see in the downside, it is control. Yellow is the N response, P response, K response. And this pink bar with a mark of asterisk, it shows the fertilizers we are adding. We are continuously adding to the soil since 1970 to 2005. Out here you can see right now, our fertilizer added is much more than what actually being utilized. This data is of irrigated areas. Means there is a gap in the irrigated areas. The emerging since the inception of the soil testing in 1955, because in 1950s we felt there is some issue. There we are having some issues of nutrients and availability of the nutrients in the soil. And it was found that in 1950s we were the soils were found to be depleted of nitrogen. In 60s, nitrogen and iron. It went on increasing up to 2020 by up to MO, molybdenum. Right now in 2025, we don't know what another nutrient will be added in the group, which will be depleted from the soil or which won't be available. Or maybe it may be available, but it may be in the fixed form. And there may be some synergism or antagonism, and there may be some other factors which may not be making this nutrient available, which may be stopping this or restricting this nutrient to be available to the plants for their sustainable growth. See out here in this, it is shown in the yellow, it is a little bit light in color. This is the removal of nutrients. The red one, it is the mining of the nutrients from the soil, which we are right now mining. And the removal is the top one, yellow one. See, the addition is only up to the green portion. Means there is a gap. We are in negative. What we are adding, whether it gets lost or it gets fixed. And that is why there is a net negative soil nutrient balance in our soils right now. They are degraded. We can say soils have gone into the fatigue. Thake hui soils hai. Keeping in consideration the above issues, soil health management states the formidable challenge to optimize crop production while maintaining the soil health. The main factors for which the soil health came into existence was low production. Previously, the indigenous varieties, right now you might be knowing at our own places, we are having some indigenous varieties of field crops, let it be cereal crops, field crops, or any other vegetable. There was low production. But in green revolution, there were high yielding varieties were introduced, but they needed high fertilizer amount, high nutrient amount. And for that, the fertilizer use was enhanced. The fertilizers, as soon as fertilizers got enhanced, the crops became succulent and the luxurious crop plants came into existence. And due to which there was large and high level pests and disease incidences. And due to that, we again started the indiscriminate use of pesticides to control that. And right now we are having in our food and in soil both the alarming rates of these chemicals and herbicides, weedicides, which are not good for our health. They are carcinogenic in nature. And the only answer to these is to go for the maintenance of soil health. See, there are certain factors or principles for soil health. That is number one, minimum disturbance to the soil. Then maximum, we should cover the soil canopy. Then we should integrate our system of farming. We should introduce the livestock in it. Then we should not keep our land fallow. It should be continuously cultivated by, at least there should be some living system or living root system in the subsoil surface, and increase in biodiversity. We should not always grow from same cropping at a particular piece of land. The approach to the soil is in a three-way. It is physical, chemical, and biological. Under physical, there are certain factors of texture, structure, porosity, water retention, aeration, and thermal regime. And under chemical, there is a reaction, means pH, cation exchange capacity, the nutrient reservoirs, and their synergistic antagonistic oscillation effects. And the biological health, soil biodiversity, soil organic carbon pool, pests and pathogens. Out here, the soil health indicators, see, biological environment, physical environment, chemical environment, and organic matter. Organic matter alone is the main factor in which the plants, microorganisms assimilate, and they create a sub-life at a particular rhizospheric zone, or in a zone where there is high organic carbon content, means it is live. The soil health management, it includes the judicious use of chemical fertilizers, including secondary and micronutrients in conjunction with the organic manures and biofertilizers for improving soil health and the productivity of the soil. The strengthening of the soil fertilizer testing facilities to provide the soil test-based recommendation to the farmers for improving the soil fertility. Although the soil testing has started in India by 1955, just merely by 16 soil testing labs. Right now, we are having 1,049, but still there is a need so that we can enhance it, so that everybody can know the proper capacity of the soil, because under soil, there are two terms: capacity and land capability classification and sustainability. Capability is one thing, means what the capacity is, but sustainability means how long we can use that thing. And for that, the upgradation of the skill and the knowledge of the soil testing laboratory staff, extension staff, and farmers through training and demonstrations. Under agriculture management practices, we are having both, by which the soil health can be promoted and by which the soil health tends to reduce. Under which the reduction of the soil health occurs aggressively. Tillage is one of the factors. Annual and seasonal fallow, we keep the piece of land, we keep it fallow for season, or annually we keep it fallow. That is one of the important aspects for reducing the soil health. Monocropping, continuous cropping of simple or single crop, annual crops, excessive inorganic fertilizer use, excessive crop residues and removal of those, broad spectrum fumigants and pesticides, and then broad spectrum herbicides. On the other hand, by agriculture management practice itself, there are certain factors which help us in
Dr. Sir, you are not audible. Dr. Aziz.
Organic fertilizer use, that is manures, compost, crop residue retention, integrated pest management, weed control by mulching. Then managing the soil health, we should always keep in consideration the 4 R's, which help us in maintenance of soil health and better crop yields. These 4 R's refer to right source, right rate, right time, and right place. Balanced nutrient management must look at the factors such as nutrients present in the soil and the nutrient removed by the crops, fertilizer input costs, investment, profitability, agricultural methods, moisture, physical condition of the soil, degradation conditions such as salinity, alkalinity, and acidity. For nutrient management these options, certain things should be going hand to hand. Amongst them is integrated nutrient management, the balance of fertilization, fortified and customized fertilizers, soil test-based fertilizer recommendation, crop diversification, and soil amendments. On the right side, it has been shown right now, these are the available things which you can easily get from market, or at home level you are having these things. And it will maintain and manage the soil health, and agriculture will become sustainable. The benefits and the challenging of using these biological manures, or the way by which particular biological things are being stressed, they are having certain benefits and challenges. The benefits are improved soil organic matter, better soil structure, enriched microbial diversity, sustainable and environmental friendly, reduced commercial fertilizer use. But the challenges are we are facing too much order and flies, complicated produce or procedure for production of these things, storage and handling, lack of accessible application area, and low nutrient levels. Integrated nutrient management is one of the remedy for soil health and productivity, hand to hand, both things. Because it is the conjunctive use of chemical fertilizers, organic matters, and biofertilizers to maintain the both soil health and as well as for the yields, higher yields. Need to augment supplies of organic manures, fortified, coated, customized fertilizers, supplying secondary and micronutrients together, biofertilizer and soil amendments to have INM on sound footing, and site-specific nutrient management. Fertilizer policy measures should be taken in consideration: nutrient-based pricing and subsidy. The pricing of the fertilizers and subsidy on them to be fixed as per the nutrient content, not the product wise. The move to encourage the use of complex and broadened fertilizers and balanced fertilizer use rather than mono fertilization. And the new pricing mechanism would reduce the dependence on DAP. The SSP containing 11% of sulfur to be promoted to correct widespread sulfur deficiency in the soils besides pre-source. Right now, the sulfur is one of the important issues. The promoting of fortified and coated fertilizers. The fertilizers to be fortified and coated with the micro and secondary nutrients. Most of the people, you must be knowing neem coated urea, zincated urea, or urea in the form of pills and other things, so that they can be continuously, because every nutrient has its own fate. Some get fixed, some are dynamic, they get lost by nitrification, denitrification, ammonification, and some get fixed, and some are affected by the pH value of the soil, means the soil reaction, and some micronutrients, they get chelated, and some are having synergistic and antagonism effects on each other. Then the policy decision by the government to allow additional cost on the fortification and coating of manufacturers, it can be enhanced by 5 or 10%, so that, but farmer will get a good quality of fertilizers, and it should be on broad spectrum basis. Then promotion of fertigation and water soluble special fertilizers. Fertigation increases the nutrient use efficiency by 40% and can be popularized for fruits, vegetables, flowers. Although it is not good for field crops, under this situation we are restricted to these crops only, because drip cannot be gone for cereal or field crops. Similarly, hold a great promise as a micro irrigation to be expanded on 69 million hectares in a subsequent plan periods. The fully water soluble fertilizers are costly due to heavy custom duty and sales tax, which can be reduced and which can be made duty free, need to be manufactured in India and brought under the Fertilizer Corporation Act. Then strengthening the soil service. This is one of the important aspects for balanced plant nutrient, this nutrient management for enhancing the soil, this health. The service presently inadequate with the capacity to analyze only 7 million soil samples. As I have told you right now, previously it has started with the 16 labs. Right now we are having 1049 labs, but still that is not sufficient. We should have more soil testing laboratories. Although right now we are having private soil testing laboratories, particularly in Maharashtra. They go for soil testing before they go for anything, but still that is not sufficing our need. Then second, need open more soil testing laboratories. The laboratories to be a participate in the preparation of georeference soil fertility maps of the district and block level, so that it can be easily accessible to all the people. The National Commission on Farmers has to be recommended additional 1,000 advanced soil testing laboratories in the country to augment this need. Then there are some policy initiatives. Under that, the coating of urea with neem oil, it should be enhanced, and it should be gone for a widespread production. Integrated watershed management programs, National Mission for Sustainable Agriculture, National Mission, all these are right now, but it should be, these policies should be, the benefit of these policies should be in the real means, and it should reach each and every house, particularly the ones who are right now attached or allied with the cropping systems or allied with the agriculture or horticulture. The priorities areas which need to be addressed. These are new tools for techniques of soil testing based specific balanced and integrated nutrient management, liquid fertilizer use, and the use of organics. Then conservation agriculture and precision farming, soil and water conservation and land reclamation, bio-waste management. There are some now, at this point, first of all, I will tell you, see, the balanced nutrient is equally important. Like this, I can say you, say for example, if a human being goes to take a food, let it be lunch or dinner, in that plate we are having different things. Particularly in Kashmir we say rice and then sabzi. Similarly in Jammu, maximum people they prefer roti and sabzi. See, under this rice and sabzi or roti or sabzi, rice and roti, if we will eliminate that, in sabzi we are having first of all a vegetable, then oil, then a certain quantity of salt, certain quantity of turmeric, certain quantity of chili. Means if we remove any of one of the ingredients from the food won't be tasty. Similar is the case with soil. There are certain nutrients which are put in a category of major nutrients, certain are put in secondary, and certain are put in micronutrients, which are required in very less quantity, ppm. But if we remove any of these are equally, just like our food, these are equally important for a plant growth. All these, because major are termed as major because they are required in large quantity. But minor, they are also equally important, although the quantity is less, but they are equally important. So now, For this, the major constants for soil health management or soil health are the lack of awareness among the farmers about the benefits of soil test-based nutrient application and crop rotation, imbalance and non-judicious application of fertilizers, non-filling of sufficient technical posts leading to the non-functional soil testing laboratories, non-availability of alternatives to the chemical fertilizers. Right now, we can't, at a stretch, we can't go for transferring from chemical to organics, because then the production will be zero right now, because our soils are too much degraded right now at this point of time. Non-availability of relatively low-cost FIM, although we are having at our minor scale, low this households we are having, but that is not a well decomposed FIM. So the availability of good FIM that is not available right now everywhere. Then the non-availability of good quality green manures and seeds in adequate quantity. The interventions for the soil health management, for balanced nutrition and other things, there are certain interventions. Amongst them is the technological intervention, the diversification of soil testing system, and the capacity building and awareness amongst the new generations. Among the technological interventions, we need incorporation of crop residues and promotion of green manuring, promotion of bio-enriched compost and vermicompost, establishment of soil testing facilities at village level and use of fertilizers according to the soil test, judicious use of pesticides to control the degradation of the soils. Then under diversification, promotion of soil testing laboratories in public partnership, model in infrastructure and support from the state, this UT and states, soil health managers at the village level with a mini soil kit too, so that they can get the assistance from the state and central level and mitigate the needs of the farmers at their doorstep level. Then under capacity building, the training and regular trainings and demonstration to the farmers for creating awareness through mass and print media, ensuring soil health card of each farmer in each field, particularly to the tune of 1 hectare, and self-certification about adoption of organic farming. A well-known Peter Morin, he is a French Catholic and an environmentalist. He has put it like this: it is impossible to have a healthy soil, healthy and sound society without having a proper respect for the soil. Means the more we degrade or deplete the soil, the more degradation will be there in our human life. Thank you very much. Over to you, Dr. Aiser. Any questions or something else?
Yeah. Thank you, Dr. Saab. Thank you very much. You have discussed in detail about the balanced mineral nutrition for soil health. You have rightly said that soil testing is must before the application of the fertilizer. And just keep in mind the particular thing, that is 4 R's: right source, right place, right time, and right rate.
Yeah.
So, and the adoption of a farming system model is very necessary to economic point of view. So now it is open for discussion, and I request the participant, whoever have any doubt or question, may unmute themselves and ask the question. Yeah, participants, anybody? Mr. Kumar Anshuman?
Yes, sir.
You want to ask anything?
No, sir.
Okay. Anybody? Any doubt?
Yes, VK Yadav sir, you can say what you want to say. You have raised your hand, sir.
He is raising hand from morning.
Sir, convey my regards to Division of Soil Science, particularly to Vikas sir and Arya sir.
Yeah.
Because in the meantime, while delivering the deliberations, I have seen Arya sir somewhere, but
Yeah.
convey my regards to everybody, and thank you very much, sir. Thanks to all.
Thank you, Dr. Saab. Thank you very much.
No issues. Thank you very much.
Okay, thank you. And this is all of today's session. So now I request you all that again join us tomorrow at 10 a.m. sharp. So till then, you have to join tomorrow with the same link. And tomorrow is the last day of training drive, so all are requested to be present at time. And after the lecture, there is a evaluation quiz. So Okay, any participant want to ask anything, any doubt? Okay, thank you very much. This is all from today.